Hello and welcome to this webinar from Azul Systems. How difficult is it to move to a different OpenJDK distribution? My name is Simon Ritter. I'm the Deputy CTO at Azul. Obviously, the purpose of this webinar is to help you understand about migrating applications from using different builds of JDK, probably Oracle JDK, to builds of OpenJDK. We'll talk through the different aspects of that, understanding what's important about the distribution that you're going to use, what are the steps to go through to make that migration, and so on. But before I get started, a couple of housekeeping things. One, we will be recording this session, and so we'll send a link afterwards to everyone. So if they want to share that with their colleagues, with their friends, or even their family, then they can do so. And we will have time for Q&A at the end. So if you do have some questions, please feel free to type those into the Q&A section of the Zoom webinar software. Right, so let's get started then in terms of understanding what we're doing. So the first thing is to have a more clear understanding about OpenJDK itself, because often when I talk to people about what Java they're using and I say, well, which distribution are you using? And they say, oh, we're using OpenJDK. And that is probably quite accurate in the sense that they are using a build of OpenJDK. It's a bit like saying, what operating system are you using? And people say Linux. Well, that's great, but what distribution of Linux are you using? Is it Ubuntu? Is it Red Hat? Is it SUSE or whoever? And the same thing applies with OpenJDK. So what we need to understand is that OpenJDK itself is the source code to the Java platform. It's actually the reference implementation of the Java SE standard. So you know that that's where everything is being developed, but it is just source code. And the way that this is developed, just to give a little bit of background on that, is that we've seen changes a few years ago where we moved away from having multiple years, 2, 3, even 4 years between releases to a very time-based idea where we have 2 releases every year, March and September. And this has been working really well. We've seen a lot of changes to the Java platform in terms of delivering new features, things that developers want to make their lives easier, to make applications more robust, more secure, and so on. The other thing to understand about OpenJDK as a source code repository is that there are updates, and those updates contain security patches and bug fixes. And those updates are issued 4 times a year. So we've got 2 new versions every year, March and September, but then we've also got these updates which come out in January, April, July, and October. And again, those will then have to be delivered through the distribution because the changes have been made to the source code. And one other very important thing about that is that the source code changes from those security fixes and bug fixes are only made directly to the current release of the JDK. So right now that's JDK 21. If you want support for older versions of Java, then somebody needs to take those changes in terms of the source code and then backport them to the older versions that will require continued support. And we'll talk a little bit more about that later on. So the key points to get across here is the fact that OpenJDK is source code only. And if you want to use it, then again, in the same way that if you want to use Linux, you need to get a distribution of it that you can install on your machine and then run your applications on top of. So in terms of the distributions, I've put this diagram together to kind of help make it clearer how this all sort of works. In the middle, we've got the OpenJDK, the source code itself, the repository where you can go, you can access it. It is, because the name's OpenJDK, it's open source. You can go and download it, you can look at it, you can play with it, you can build it if you want to. And the way that contributions work to that is in the same way that many other open source projects happen, where lots of different people will be involved in contributing changes to that. Obviously, Oracle, as being the company that owns the Java trademark and really the ones that oversee the OpenJDK from a lot of the major changes, they make the bulk of the changes to that. But there are lots of companies and lots of individuals who also contribute not just bug fixes or security patches, but new features as well. So Azul is clearly one of those. We've got people like Red Hat, we've got people like Amazon, Microsoft, and so on. So there are many companies, many individuals who contribute to that. All of that goes into the source code, as I said, and in terms of the way that the source code is progressed, we have these different versions, different repositories for each version. What you then need to do is find a distribution of that where somebody takes that source code, runs the build scripts, and generates something that you can install on your machine to run your application. Now, in terms of what you get for that, obviously there's the Oracle JDK that you can get if you go to the Oracle website. Azul, as I will explain during the rest of the presentation, have a build of OpenJDK called Zulu, and then we have commercial support around that, which we call Platform Core. There are other distributions. So Amazon has one called Corretto that they use to run applications if you're using AWS. Microsoft have a distribution so that if you want to run your applications in the Azure cloud, and there's Temurin from Adoptium, which is a free build that you can get from the Eclipse Foundation. So as you can see, lots of input goes into OpenJDK, and then people take that and they build a distribution that you can use to run your applications. Now, one of the very important things about how you choose which version of Java to use is around whether you have continued maintenance and support for those releases. As I said, all of the changes in terms of source code happen for only the current release, JDK 21 right now. But if you want to carry on using older versions, you need to find somebody who has a distribution which will continue to provide security patches, continue to provide bug fixes for that. Now, what happened when Oracle switched to the idea of a 6-month release cycle for OpenJDK was the Oracle distribution. They said that it would be unreasonable to continue to provide updates for all of the different versions because it was going to become very difficult with lots of versions over a short space of time. To get around that, they decided they would use the same approach that people like Ubuntu do for their Linux distribution. And they said that they would nominate certain versions as being long-term support releases. The idea being that you would get continued updates to those for an extended period of time. Other ones which are not long-term support only get the updates until the next release. So if you look at JDK 20, for example, they had 2 updates, and then when JDK 21 was released just a couple of months ago, that terminated any further updates to JDK 20 because it wasn't long-term support release. Now, the plan originally when Oracle announced this was that they would have one long-term support release every 3 years. And the way that they started this off was that they said because most people at that time, going back to 2018, 2019 at this point, most people were using JDK 8. So they said that to enable people to continue using that for a period of time, they would make that a long-term support release, even though it had already been released. And then the next one would be JDK 11. When JDK 11 came out, obviously the clock started ticking, and the idea was 3 years later, JDK 17 came out, and that was the next long-term support release. Just to make life a little bit more interesting, Oracle then decided that they would shift from having 3 years between long-term support releases to 2 years between long-term support releases, which means that after JDK 17, we only have 4 releases. So JDK 21 is the current long-term support release. Now, again, important thing about this is that from an Oracle perspective, that's for the Oracle JDK. Other distributions are free to choose how they deploy in terms of which versions they continue providing updates to, maintenance and support, and so on. But the good news for users is that all the distributions have aligned along the same long-term support releases that Oracle have. So if you go to Amazon, if you go to Temurin, if you go to IBM, all of them will have the same long-term support releases, 8, 11, 17, 21, and so on. So that makes life a little bit simpler in terms of choosing which version to use. If you're interested in having extended maintenance and extended support, then those are the ones to choose from. If you're not so worried about that and you want to keep moving at the latest update and the latest version so you can get all those new features, then you can change every 6 months. And when JDK 22 comes out in March of next year, then you'll be able to use that when it comes out. So it's entirely production ready. It's not a problem. Now, in terms of one of the key things about having extended maintenance for your Java runtime is making sure that it is as secure as possible. And the way that that happens is through a group within OpenJDK. It's called the OpenJDK Vulnerability Group. What this is it's a group that was formed by Oracle initially because they saw that there was a proliferation of distributions of the JDK, and they wanted to ensure that the people who were providing those distributions had access to all of the security patches so that they could maintain that level of security for Java overall. They created this group and they invited different companies, different individuals who were working on distributions and the security aspects of that. So you have people like Amazon, you have people like SAP, you have Azure, Microsoft, and so on. All of those contribute engineering resources to this group. Very important thing about this group is that it isn't public. All of the information that is shared between the members of the group is kept private, and all of the email is encrypted, so there is no publication of any communications or any details about what the team are working on. That's very sensible because the reality is that when we're working on new security patches, that means we're addressing vulnerabilities that have been reported in Java. And if we make that information public before we have the vulnerability addressed and resolved, then there's the possibility that people could then try and exploit those and attack systems. So we make sure that all that information is kept private until we have patches for those updates. And then when the update comes out, you will see a list of the vulnerabilities that have been addressed. So you know, okay, these are the things that need to be patched. And you also have the details of what the vulnerability is and how severe it is in terms of a number. So you have a CVSS score associated with that. So very important that we have the ability to address all of these security vulnerabilities in a timely manner. Now, the good thing for us as a distribution provider, and this applies to other distribution providers as well, but not all of them, because not all distributions are a member of the vulnerability group. But from Azure's perspective, what we're doing is we're actually developing the security patches along with Oracle, Amazon, SAP, and so on, which means that our engineers have advanced visibility of the code that's being developed and the changes that are necessary in the current release. We can then take those changes and we can look at what needs to be backported to older versions, to the 17, the 11, the 8, and maybe even older versions, where we need to take those changes and then apply them to the older versions so that we can address security vulnerabilities that are in those. Now, that won't mean that everything gets backported, because if you've got a feature that exists in JDK 21 that doesn't exist in JDK 8, for example, then there is nothing to backport. But anything that needs to be backported can be. Second thing we can then do is we can take those backported changes, we can build the distribution with those changes, and we can do the testing to ensure that everything still works in the way we expect it to. And I'll talk a little bit more about what's called the TCK in a moment. But having done all of that, it means that when the update is released and what's called the embargo is lifted on distributions being able to make that available, then we are able to make that available simultaneously with the Oracle JDK. Now, I say simultaneously in quotes there. It is essentially simultaneous. By that, I mean that we have had a record in terms of going back to when Oracle changed the way that they did updates and distributions to having our update available within 60 minutes of Oracle. So there really isn't any time that somebody could look at the changes, look at the vulnerabilities that have been exposed, and develop an exploit to that and try and break into your systems. You've got the updates available immediately. You can deploy them whenever you want to. Other distributions may not be as quick, so this is something that you do need to consider when you're thinking about which distribution to use. Other distributions can be days behind, they could even be weeks behind in terms of that update, and that does provide a window of opportunity, especially if it's weeks, for people to say, right, so we can see what that exploit, or we can see what that vulnerability does, we can create an exploit for it, and then try and find systems that haven't been patched. Now, a lot of people will say to me, well, how important is it to have these updates? I mean, Java's 28 years old now. Haven't we identified all the vulnerabilities, the critical vulnerabilities, and surely everything is now safe? That's not the case, though. You have to think that Java as a platform consists of over 7.5 million lines of code, and it just isn't practical to say that we have eliminated all possible security vulnerabilities. And remember that Java gets built with external libraries as well, the platform libraries like Windows and Linux and so on. So there may be vulnerabilities that are detected in those, which then need to be incorporated into a build to address those vulnerabilities. If we look at this slide here, what I did was I went back all the way to when Oracle stopped providing free updates to the Oracle JDK, and I looked at what was the highest scoring vulnerability in each of the updates that we've had since then. The good news is that we only saw one 9.0. That's a critical vulnerability that needs to be addressed very, very quickly. But we have had a number of high vulnerabilities in the sort of 8.6, 8.3 range, and we've had plenty in the medium range. Recently, we've had quite a good sort of selection that have been quite low, but that doesn't mean that we won't see high in the future. So it is important, if you want to maintain the security of your systems, to have access to all of these updates. Now, testing, I mentioned this thing called the TCK, and that's a very important thing to understand about, because we have a standard for Java. This is created through the Java community process. There are expert groups formed for each version of Java, and there is what's called a Java specification request. And the Java specification request consists of three different things. Firstly, there is the specification itself. Definition of the Java language, the syntax, there's a definition of what the JVM needs to do from a functional point of view, and there's a definition of what are the core class libraries that need to be included in Java. That's how you get the write once, run anywhere idea, because everything has to conform to this standard if it's going to be called Java. So you know you've got the same syntax for the compiler, you've got the same functionality in terms of the way that the JVM works, and you know you've got the same set of standard class libraries. So that's the specification. Then we have a reference implementation, and I mentioned earlier that that is what OpenJDK is. So it's the reference implementation of the standard. It's used to demonstrate that you can actually implement this specification. It is possible to implement it. And then the third part is what's called a technology compatibility kit. And the technology compatibility kit, or TCK, is about having a set of tests that you can run on a distribution that has been provided, a binary distribution, to verify that that distribution conforms to the standard. Now, because most people are building from the OpenJDK source, you would think, well, OpenJDK is the reference implementation, therefore, by definition, it will pass the TCK. But remember that there's a lot of details to how builds work and how you construct a distribution. So things like using different libraries, external libraries may have an impact, using different command line flags, compiler options may also have an impact on that. So it's very important to run all of the TCK tests and verify that even though you built from OpenJDK, it does pass all of the tests and therefore conforms to the standard. Because that will also give you a very high level of confidence that if you're moving from one distribution of OpenJDK to another distribution, that your applications will behave in the same way, because functionally, the distributions are identical. Now, in terms of the TCK, technically, it's actually the Java compatibility kit, because TCK refers to more than just the Java platform. It's lots of other parts of the Java specifications. And there's over 150,000 tests, depending on which version of Java you're running. And like I say, it gives you a very high level of assurance that your binary is going to match the standard, and therefore you can move very easily without having to change any code, without having to recompile any code from one distribution to another. Let's talk in a little bit more detail about our Azul Zulu core builds of OpenJDK. So essentially what we're doing here is we are taking the OpenJDK source code and we're building it to create a distribution. And then we run all of the tests on the builds that we create. Now, I have to say here that we provide maintenance and support for all versions that are long-term support. So JDK 6, JDK 7, JDK 8, JDK 11, and JDK 17, and now JDK 21 as well. So that's now a long-term support as well. So we run the TCK on all of those except for JDK 6 and 7. Now, the reason that we don't run the TCK on those anymore is because Oracle no longer provides even extended support for those versions of Java. Because of that, they have now withdrawn the license for the TCK for those versions, so we're not able to run that. But we know that from the work that we've done previously that we passed the TCK, so we're very careful in terms of the changes we make, looking at how we backport any security patches or bug fixes to ensure that we can still provide that functionally identical way of running your applications. As I said, Oracle have stopped providing support for JDK 6 and JDK 7, and in fact, everybody else has as well. So we're the only distribution that's available that has support for JDK 6 and JDK 7. If you're running these very old versions, you're not in a position to move off those, then we can still provide support for that. We also have very wide platform support. So we provide the standard Intel 64-bit operating systems, Windows, Mac, and Linux. Some people are still running on older operating systems like Windows XP. There are plenty of people out there still using that. And so we can provide 32-bit builds for both Windows and Linux. We also have Solaris builds if you need them on Spark, and we have ARM32 and ARM 64-bit builds as well. And we even have some builds for things like PowerPC, but those are more for embedded applications. Now, another thing to be aware of is when you're looking at distributions is the fact that each update is delivered by Oracle for the Oracle JDK in two forms. There's what's called the CPU and the PSU. And Azul matches what Oracle provide, so we also deliver both the CPU and the PSU. Now, CPU is a security-only update. What you get there is only the changes that are related to security vulnerabilities. And if you look at the typical update, you'll find that there's not that many changes related to security. Number of CVEs that get addressed is anywhere from about 2 or 3 up to at most less than 20. So we're talking about a very small set of changes there. The idea of having the security-only update is that if you're concerned about security and you want to roll out changes to maintain that level of security to its highest level as quickly as possible, then you use the CPU because it's going to have the minimum set of changes and therefore the minimal potential impact on stability of your applications. The reason for that is if we look at the other update, the PSU, which is the full update, that contains those security changes plus everything else, all the bug fixes, any performance improvements, things like that. And that will run into 200, 300, even 400 changes. So there's a lot more changes in the full update than there are in the critical patch update, the security only update. That means that there's a lot more potential for changes in that update to impact on the stability of your applications. Now, to give you an example of that and why having the security only update is very important, let's go back a couple of years to July 2020. There was an update there, and in that, there was a bug fix that was included for JDK 8. So JDK 8 update 252, that had a bug fix for something that had been reported. It was fixed, it was included, but because these updates happen every 3 months, it's just not practical to be able to test every piece of software against changes that are being made. So obviously we run the TCK, and there's generic testing of various things to make sure that things work in the way you expect them to, but we can't test everything. And what that update included was this change which had an impact on some fairly major pieces of software, specifically Hadoop Cluster, Solr, and Lucene. Because of the change that had been made to address that bug, that then meant that those pieces of software wouldn't work in the way they were expected to. In fact, they wouldn't even start up with that bug fix included. It took Oracle 2 weeks to resolve that, to fix the fix, and then include it in a new update, update 255, I believe it was. And the thing is that if you had access to the security-only update, update 251, then because it didn't include that bug fix, it meant that you could have deployed that onto your systems using Hadoop Cluster, Solr, and Lucene without breaking those applications. They could still continue to work, deliver on the functionality you needed. Now, in terms of that particular update, the highest scoring vulnerability was 8.3. That's a medium. It's not a critical, but it's quite high. Sorry, it's a high, not a medium. It's a high, not a critical, but it could have been a critical vulnerability. If that was a critical vulnerability and you needed to address it quickly, you wouldn't be in a position running Hadoop Cluster, Solr, or Lucene to be able to use just the full update. You would have had to have the CPU available to resolve that vulnerability. So that's why it's important to have that security-only update. Now, that's one example. Does that really happen that often? Actually, it does. So if we look at, again, going back to January 2019, which is when Oracle stopped providing free updates to their JDK, there've been 19 updates since then. And of those, 6 have had stability issues in the PSU. Now, that might sound quite bad. I mean, that's a 30% failure rate. But remember that, when we're making changes to things, you can't test everything each time you go through there. And so the chances of this happening are quite high. But it does mean that with that kind of need to address vulnerabilities quickly, having access to the security-only update is very, very important. Now, in terms of the goal of this presentation was to talk about how easy it is to move to a new distribution. Now, what we recommend here is to use a three-phase approach. The first one of the phases is to discovery, and find where you're using Java. This is actually, for many of our customers, is the longest part of the process, is the hardest part of the process, because Java being 28 years old, people have gradually installed more and more applications that use Java over many years, and it's maybe not been done in a rigorously defined process way. So you end up with not knowing where Java is actually running, and you have to go through, look at all your machines and figure out what machine is running which version of Java to run which applications. So determining where you're using Java, which versions, even which updates, is often the biggest part of that. You can use things like software asset management software if you have them, but if you don't, then it's more of a manual process. We do have some scripts that you can run to test on a machine to find out which versions of Java are installed. You can do things like looking at the process table to find out where Java is actually in use at a particular time. And so there are things that we can use to help that phase. The second phase is taking a list of all the places where you're using Java and then installing the new version or the new update of the distribution that you want to switch to. And again, that can be done in a couple of different ways. If you want to, you can simply install the latest update of the version that you're running for that application. Or if you're more concerned about stability again, you could do a like-for-like installation and say, right, we want to install, let's say, JDK 8 update 252 to make sure that we have the same update that we're using at the time, and then make a switch to the new update. That's if you're very conservative and you need to make sure that there aren't any changes between the different updates which might impact on, again, on the stability of your application. Third phase is making sure that having installed the new distribution of JDK, that your applications are going to run in the same way that you had them before. So testing is what we're doing there. And that can take a number of different sort of approaches. If you've got very rigorous testing, you've got regression tests that you can run, then you can run all of those and verify that your application does exactly what it's supposed to do. Or if you don't have that more rigorous testing, you can do things like touch testing. You can define your own set of tests just to verify that the application works in the way that you expect it to with this new distribution. There isn't any reason why it shouldn't work in a different way, but it's that validation to make sure that you're happy that your applications are behaving in the way you expect them to. Now, a couple of other things to be aware of. From the server side, if you're using server-side applications, then there really aren't any issues to worry about, because when you switch from one OpenJDK distribution to another, then having been built from the same source code, having run the same TCK tests, everything is really identical. But if you're running desktop applications, they may require some additional work. There were what were called desktop deployment technologies, specifically applets and the web browser plugin, and then Java Web Start was another way of deploying applications. If you've used those, because they're not part of OpenJDK, they don't get built as part of a distribution. So the Oracle JDK included them up to JDK 11. They were removed in JDK 11 from Oracle. But if you're using JDK 8 or 7 or 6, you may be still using Java Web Start or applets. There are ways around that. There's a thing called ICT Web. It's an open source alternative to Java Web Start. You may require some configuration changes to make your application work in the same way, because it's not a like-for-like replacement in the same way that OpenJDK builds are. What we found is that in helping literally hundreds of customers migrate from Oracle JDK or other OpenJDK distributions to Azul's Zulu distribution, that we haven't seen any issues that we can't resolve. Our SEs are very skilled at helping people. They understand the issues that they've seen, and so we know what to do with that. And in fact, what we've done is we've written a book on this. I wrote this book called OpenJDK Migration for Dummies, and it goes through all of the process that I've just talked about. It goes through all the details about how to choose an OpenJDK distribution, a lot more detail about TCK and the open source nature of Java and so on. If you want to, you can download that for free. There's azure.com OpenJDK Migration for Dummies link there, and you can download that without any cost at all. Just to summarize then, Azure Platform Core is a build of the OpenJDK. What we provide there are TCK tested binaries. Again, I'll just reference that JDK 6 and JDK 7 aren't TCK tested because the license has been removed by Oracle, but all of the other builds are fully TCK tested. All of the updates that we provide are available within a time-defined service level agreement. As I said, we've had all of our updates available within 1 hour of Oracle. So basically, we're talking about very quickly there. All security patches, all bug fixes for all updates are backported where applicable. So as long as the feature exists and it needs to be backported, we will do that. We also provide, as I said, both the CPU and the PSUs. So you have this flexibility if you want to deploy just the security patches very quickly without impacting on stability of applications. If you need the full update, then you also have that as well. We also have the standard 24/7 support, issue reporting. Our support team is very experienced with helping customers to understand how to resolve issues. And if need be, we will address that through the OpenJDK. We will create a separate build for an application for a user to address an issue, and then we will upstream that into the OpenJDK to make sure that other people can also take advantage of that changes. So essentially what we're doing here is providing you with maximum security, maximum stability, maximum flexibility, but at a lower cost to other alternatives. So with that, that is the end of the presentation. So what I'll do now is I'll just see if we have any questions. So I've got one question here, which is, Oracle have changed their licensing and pricing several times over the last few years. Do you think that this will change again in the future? That's a very good question. I don't work for Oracle. I used to work for Oracle, but I don't work for Oracle anymore, so I can't obviously give a definitive answer to that. It is interesting that they have come up with a number of different changes, as I said, both to the licensing. So we have the Oracle binary code license, we have the Oracle Technology Network License Agreement, and we also have the no-fee terms and conditions license, which applies in different places to different distribution or different versions. So will they change it again in the future? I don't know, but based on what we've seen in the past, there's probably a reasonable possibility that they will make some changes at some point to either change the licensing or the pricing that they use for that. Okay, so I don't see any other questions there, and I think we're just about on time for the webinar. So I will say thank you very much for listening, and that is the end of the webinar.